All right, class, today we're going to talk about geometric probability. First, let's talk about regular probability. It is a number from 0 to 1 that indicates how likely an event is to occur. This can be written as either a fraction, a percent, or a decimal. Let's look at if we have a probability of 0, what that means. It means that the event cannot occur. The likelihood of that event occurring is 0, which means it will never happen. On the other hand, if our probability is 1, this means that the event must occur. It will for sure happen. There's a 100% guarantee that that event will occur. All right, we write probability in this formula where the probability of an event equals the number of favorable outcomes over the total possible of outcomes. Okay, next we're going to talk about geometric probability, which is a probability, same definitions as above, but it involves a geometric measure such as length or area. So the first one, right here, involves length. It says the probability of an event dealing with length is equal to the length of the favorable segment that we want divided by the length of the entire segment. All right, the second one deals with area. It says the probability of an event is equal to the area of a favorable region divided by the area of the entire region that we have. You will see me write this as part divided by whole. Instead of having to memorize all three of these, you can just memorize the one, part over whole. You'll see me write that a lot. Okay, so let's look at our examples down here. Our first example says, inside a bag there are 3 yellow balls, 4 red balls, and 5 green balls. What is the probability that you will pick out a red ball? Okay, so I look up here at probability and geometric probability, and I see that I'm not dealing with length or area, so this must be just a regular probability problem. So we want to deal with the first formula where favorable outcomes is divided by the total possible outcomes. Okay, we can still do part over whole though, where the part is what we want. We want to pick out a red ball, and there are 4 red balls, so that goes on top. The whole is how many total balls there are, which is 3 plus 4 plus 5, which is a total of 12. This reduces down to 1 over 3, which is equal to 0.333 repeating, or in a percent form is going to be 33%. Okay, any of these answers are correct. So that was dealing with just regular probability. Let's go to the second example that is dealing with length. It says find the probability that a randomly selected point from the line segment AD lies on the line segment BC. Okay, so this is dealing with length. We want the length of the favorable segment first. That's going to be our part, which is BC, over the whole, which is our line segment AD. BC is from 3 to 6, which is 3 units long. AD is from 0 to 8, which means it is 8 units long. If I plug that into my calculator, I get 0.375 is the probability that a randomly chosen point will be on BC. Okay, let's go to our third example, which is dealing with area. It says, find the probability that a dart thrown at the square board will land inside the circle. Okay, so we want part over whole. The part that we want is the circle. We want our dart to land inside of our circle. So we want the area of the circle divided by the whole, which is the area of the square. Okay, so we know that the area of a circle is going to be pi times the radius squared. And we know that the area of any square is always its side length squared. So first we need to find the radius of this circle. Let's go over here and look at the diameter. If I draw the diameter of this circle, I notice that it is equal to the height of the square. So that whole diameter is going to be 4 centimeters. But the radius is only half of that, which means the radius must be 2. So over here, I have pi times 2 squared divided by the side of the the side of the square, which is 4 centimeters squared. This is going to be equal to 4 pi on top divided by 16 on bottom. This reduces to pi over 4 which equals 0.785. So that is the probability of our dart hitting the circle inside of that square. This concludes geometric probability video notes. You do need to know these definitions and these formulas, also how to find the probability of an event occurring, whether it is dealing with outcomes, length, or area. If you have any questions, feel free to email me or come by tutorials. All right.